All right. Hey, everybody. We are in the next actual lesson in the Unit 1, returning a polygon to its original position. So I'm on slide 6. We're talking about rotations. Now, we talked about rotations before. That's just when you take a pre-image that's your original figure and turn it either clockwise or counterclockwise around a point. I'm going to get it a little bit more in depth this time. And then we're going to do that as we go, get the basics and then add to it, add to it, add to it. All right, so if you're on slide 6, we're going to get into our GeoGebra on rotations. Let's open that up. Oh, okay, so we got, it looks like a pentagon because pentagon has 5 sides. We've got some kind of slider down here. Okay, so yeah, you can see it's rotating. Looks like around the origin. That's its center of rotation. All right, so let's see what's going on. Okay, question 1. Use the slider to rotate pentagon ABCDE about the center of rotation R. The angle through which the pentagon is rotated is angle CRC prime, represented by the variable alpha. And that's going to be between 0 and 360 degrees. 0 is when it has not rotated at all, and 360 is a full rotation. All right, so what values does alpha of the pentagon coincide with the original? Enter the values in the table. For each value alpha that you enter the vertex that coincides with vertex C prime. Okay, so let's see what the first one's going to be. All right, so there's C turned into C prime. I'm looking for it to land on B. So it looks like it's going to be 72, and it lands on B. 72 degrees. Lands on B. Now you notice I put a capital B because all points are capitalized. Well, let's turn it some more. So now I'm looking for it to land on A, it looks like, at 144 degrees. 144 lands on A. Alright, so let's keep on going. So it looks like it's going to land on E at 216. 216 degrees. Lands on E. Looks like it's going to about to land on D here. So it's going to land on D at 288 degrees. And going to a 360. So it's about to land back on its original C at 360 degrees. There we go. All right, question number 2. How many values of alpha between 0 and 360 does pentagon primes coincide with the pentagon ABCDE? What is the significance about this number? All right. So let's see. With each 72-degree rotation, because I don't know if you guys noticed, it was 72, and then 72 plus 72 is 144. 144 plus 72 is 216. Plus 72 is 288. Plus 72 is 360. So with each 72-degree rotation, the figure maps back onto itself. There are 5. Because of the pentagon, 5 values, or like 5 mappings, because that's how many times it landed back onto itself. And that's because there are 5 sides. To a pentagon. This one just happens to be a regular pentagon. Regular means that all 5 sides are the same. All 5 angles were 72. So a regular figure is one where all the sides are the same and all the angles are the same. And yeah, that does make a difference. All right, let's see. So let's see, number 3. Now move the center of rotation R to a different position on the coordinate plane. All right, let me do that. So you know what, I'm going to go back to the original. So I'm going to click move. I'll move R. Make a difference. Okay, so it rotates around that. So I move it out to 2? Let's make it interesting. All right, so I'm going to move it out to 2. All right, next move the slider bar to rotate pentagon A, B, C, D, E. How many times does the pentagon map back onto itself in this situation? And what does this tell you about the location of center rotation? Well, I doubt it's going to map back onto itself at all, unless it goes all the way around 360 and does it. Yeah, so it's going to map one time at a 360 degrees. And that's because the center of rotation is not actually at the center of the pentagon. So you got one mapping back onto itself at 360 degrees. All right, so it does it one time. It will only map back to the beginning after a 360 degree rotation. And really that's because the center of rotation is not at the center of the object again. So there you go. All right, question 4. Move the center of rotation back to the origin. Okay, so let's move it back. Ooh, bam. All right, let's see now. Alter pentagon A, B, C, D, E by moving one or more line segments of the pentagon to a different location. Okay, so move that line segment out. Now it's kind of extended. Well, it's no longer regular, which means that it's no longer a 72 degree rotation. These are going to be kind of like wobbly. Woo! Yeah, I'm only going to wrap back onto itself at one time at 360 degrees. I'm sure that's probably what they're going to be asking, but let me look. All right. Rotate the pentagon using the slider. How many times does the pentagon map back onto itself? It's only going to be one time at 360 degrees because, again, it's not a regular figure anymore. So for you visual people, there's where it hits back onto itself at 360 degrees because it's not regular. All right, so the figure is no longer regular, so it will map back onto itself one time at a 360 degree rotation. All right, so question 5. List at least 3 shapes other than a pentagon in the table. If the shape is a polygon, indicate whether the shape is regular or irregular. Find the number of times that the shape will map back onto itself as the shape rotates 360 degrees about the center. Also note how many degrees the shape has rotated each time it maps back onto itself. Use GeoGebra if you wish. Okay, so I'll make this easy on myself. Circle, square, triangle. All right, so if I rotate a circle, well, circles don't have sides. So if I rotate it, it's going to look like the same circle. It's like when you'd have your steering wheel in your hand and you turn the steering wheel, it stays a circle. So it maps onto itself infinitely many times. Again, this will be infinitely many times because I can turn it 1 degree or I can turn it 90 degrees if I'm like taking a corner or turning at a stop sign or a red light. So yeah, it's still infinitely many. All right, square. Square is a regular figure because all 4 sides are the same and also all 4 angles are the same. So it mapped back onto itself 4 times because it's regular. All right, so I can turn it 90 degrees for like if I'm turning to a different road. I can do 90 plus 90 is 180. Or I can do 90 plus 90 plus 90 is 270. Or I can do 270 plus 90, that's 360 degrees. So degrees rotated would be 90. 90 plus 90 plus 90 plus 90 is 360. All right, so triangle's a little bit different. I just said triangle. You've got equilateral triangles and equal angular triangles where all three sides are the same and all three angles are the same. So probably to make our life easier, I should have said equilateral triangle. And that's where all three sides are the same. So it maps onto itself 3 times because it's regular. Now, I've got 3 sides, so basically 360 divided by 3 is 60. So one angle will be 60. 60 plus 60 is 120. 120 plus 60 is 300. I'm sorry. What was I thinking? 60, 60, 120, and then plus 60 is 180. So 360 divided by 3 is 120 degrees. I'm done. Come on in. I was on the last one. Come on in.
No, all I was going to say was, you tell Carmen Osborne she can't post any more snow pictures till we can post some snow pictures.
My sister just got snow, you guys. And we are in school, but she's a professor at a university, so she doesn't get out anyway. All right, yeah, I noticed that. That must be nice. See you later. All right, you guys.